Hello again. Let's talk about some more complex looking trigonometric expressions, and this one seems like kind of a monster. 2 cosine squared 3 theta plus 2 cosine 3 theta minus radical 3 cosine 3 theta minus radical 3 is equal to 0, and we're looking for all of the values that make this true over the interval from 0 to 2 pi. Well, the first thing we have to do is try to simplify this expression by factoring possibly in order to isolate a simple trigonometric form equation out of it. And whenever we have 1, 2, 3, 4 terms, sometimes it's worth our time to look to see if there's something that we can do by grouping. So let's try that out. We're going to take a look at these first pair of terms. And you notice that it looks like 2 cosine of 3 theta must be the common factor, because if we take 2 cosine of 3 theta and multiply it by the cosine of 3 theta, we get 2 cosine squared 3 theta. And 2 cosine of 3 theta times positive 1 will give us 2 cosine 3 theta. Then we look at this second pair of terms right here, and we note that factoring out negative square root of 3, the subtraction of square root of 3, gives us cosine of 3 theta again plus 1. And so now our factorization becomes apparent. We have 2 times the cosine of 3 theta minus the square root of 3 being multiplied by cosine of 3 theta plus 1 equals 0. So now let's go to our solutions by setting each factor equal to 0. So we're going to take 2 cosine of 3 theta minus the square root of 3, set it equal to 0, and cosine of 3 theta plus 1, set it equal to 0. Adding square root of 3 dividing by 2 gives us cosine of 3 theta is equal to square root of 3 over 2. Subtracting 1 from both sides gives us cosine of 3 theta plus 1 equals negative 1 right here. Let me straighten that out here. Equals negative 1. So what do we have to do? Well, we have to isolate 3 theta right here by taking the inverse cosine of radical 3 over 2. And we know that the inverse cosine of radical 3 over 2 in quadrant 1 is pi over 6. But what we're going to do right here is we're going to get the general solution first. Get the general solution over the interval from 0 to 2 pi, from negative infinity to positive infinity first. Right? So we say 3 theta equals pi over 6 plus 2 pi n. And this is in quadrant 1. We also know that cosine is equal to radical 3 over 2 in the fourth quadrant for a positive value. So 3 theta would equal 2 pi minus pi over 6. That's 11 pi over 6 plus 2 pi n. In the fourth quadrant. All right, so these are the general solutions, but of course we need to isolate theta. So that means we're going to get theta is equal to, if we take both sides, multiply by 1/3, we're going to get pi over 18 plus 2 pi over 3n, where n is an integer, and we'll get theta is equal to 11 pi over 18 plus 2 pi over 3n as a general solution right here. Then we have one more right here. We have cosine of 3 theta is equal to negative 1. Well, we know that the inverse cosine of negative 1, remember this is only on the interval from 0 to 2 pi, would be pi. So 3 theta would equal pi plus any angle coterminal with it. So multiplying both sides by 1/3 gives us pi over 3 plus 2 pi over 3n. Well, these are the general solutions. We look for the general solutions first, but we're going to use these general solutions to get our set of values over the interval from 0 to 2 pi, which is what we were after. So we're going to have to come up with a set of answers based on letting n equal 0, n equal 1, and so on until we get the end of our list. So what's going to happen? Well, certainly if we let n equal 0, that's the easiest case. If n is equal to 0, we're going to get 3 answers right here. Looks like we're going to get pi over 3 from over here. We're going to get pi over 18, not exactly in order here, from smallest to largest. I like putting it that way. And then letting n equal 0 gives us 11 pi over 18. But there are more answers right here. What happens if we let n equal 1? Well, letting n equal 1 is going to give us pi over 3 plus 2 pi over 3. That's pi. So that's a solution from right here. If we take pi over 18 and add 2 pi over 3, well, 2 pi over 3, let's get a common denominator here. That's the same thing as 18 in the denominator. If the numerator is multiplied by 6 as 12 pi over 18. So pi over 18 plus 12 pi over 18 is going to give us 13 pi over 18. And adding 11 pi over 18 plus 12 pi over 18 is going to give us 23 pi over 18 as one other value. Over 18. There we go. Now we ask, would it work if we put in n equals 3? Well, if we put in n equals 3, then we get 2 pi over 3 times 3, which is 2 pi. And so we'd be adding something to 2 pi, so there's nothing else that we can add right here. And we get a total of 6 values over the interval whose values would serve as a solution to the original equation right here. And so we're done. That's what we wanted. A little bit more work is involved here. But the key to remembering this is if you've got a multiple angle, 3 theta, 2x, whatever it is, 1, get the general solution over the interval from negative infinity to positive infinity first. Then number 2, substitute in integer values for n until you find all of the values on the fixed interval you're looking for. And that's what we just did. All right, a little bit more to come.